The histogram gives information about the heights in meters of the trees in a park. However, the histogram is incomplete. So you see here there's missing a bar in this part here. 20% of the trees in the park have a height between 10 meters and 12.5 meters. None of the trees in the park have a height greater than 25 meters. So we need to complete the histogram. Okay, so when we're working with a histogram like this and look at the frequency density, to work out the actual numbers of trees, we need to look at the areas of these bars here. For example, look at this one first. We go up to 2.5 here, and we go up here, that's going to be 1.2. So if we do 1.2 multiplied by 2.5, that equals 3. So this represents 3 trees. There are 3 trees which have a height between 0 and 2.5. So we're going to do the same with this one. So between 2.5 and 5, that's 2.5. So 2.5 multiplied by, and we go up to 2 on this one, giving us 5. On this one, between 5 and 10, okay, so that's 5. We're going to multiply by, we go up to this point here, which is 2.8. So we're going to multiply by 2.8, giving us 14 trees. And lastly, this bar here. So we're going from 12.5 here, so it's halfway between 10 and 15, up to 25. Okay, so if we do 25 minus 12.5, that's going to give us 12.5. So we know we need to multiply by 12.5, and the height up here goes along to 0.8, which gives us 10. Okay, so we need to do a bit more thinking now. We're told that 20% of the trees in the park have a height between 10 and 12.5 meters. In this area, we're going to have 20% of the trees. This means that all these other bars combined is going to be 80%. So if I add them up, we've got 3 trees plus 5 plus 14 plus 10 equals 80% of the trees. So adding these up, we get 32. So 32 equals 80%. And we can use this to work out how many trees 20% is. If we divide both sides by 8, we're going to have 10% on the right hand side and 4 on the left hand side. If we now times by 2, we can have 8 on the left hand side and 20% on the right hand side. And that's great. We know that 20% is equal to 8 trees. So we just need to fill that in here. We know along this part here is 2.5. So we're going to have 2.5 multiplied by, and what we don't know is where we're going to put our line on the frequency density. So it's 2.5 multiplied by some unknown x equals, and what we just worked out is 8 trees. So if we divide both sides by 2.5, we're given that x equals 8 divided by 2.5, which is 3.2. And since x here is our frequency density between 10 and 12.5 meters, we now know that's 3.2. We can plot it on up here. All up here we've got 3, 3.1, 3.2. So I'm going to draw the rest of our histogram on. So it's going to go up to there, a line along there, and a line down there. So you get 1 mark for working out the frequencies already on the histogram. You get a second mark here for adding them up to get 32. Then the final mark for using all of that to get down to see that our frequency density should be 3.2, and using that to plot accurately on the histogram.